You have probably been told how a wing works. Air splits at the front. The top is curved so that air has further to travel. It speeds up to catch up with the air underneath. Faster air means lower pressure and the wing gets pulled upward. It is a tidy story. It is in textbooks, in museums, on the safety card in the seat pocket. And it is wrong. The idea has a name. The equal transit time theory, sometimes called the longer path theory. It is appealing because it sounds mechanical. Two streams of air, one race, one winner. But it rests on a question almost nobody asks. Why would the two streams have to meet again at all? They do not. The air molecules that split at the front of a wing made no agreement with each other. There is no rule in physics that says they must arrive at the back together. And when you measure it in a wind tunnel, they do not. The air that travels over the top reaches the trailing edge earlier than the air underneath. Not at the same moment. Earlier. Even if you ignore the timing, the numbers refuse to work. Take the real path difference on a normal wing. Calculate the speed difference. Put it into Bernoulli's equation. You get a small fraction of the lift the aircraft actually needs. For the story to hold, the top of the wing would have to be about twice as long as the bottom. Look at a wing. It is nowhere near that. And there is a simpler objection which you can watch at any air show. Aeroplanes fly upside down. If lift came from the curve of the wing, an inverted aircraft would be pushed toward the ground and pushed harder the faster it flew. Fighter jets do it routinely. Something else is holding them up. A second explanation usually gets offered when the first one fails. The wing acts like a venturi tube. The curved top narrows the channel so the air is squeezed and has to speed up. But a venturi needs walls. Above a wing, there is only sky. Nothing forces the air through a gap. It can simply go around. So here is what a wing actually does. It takes a large mass of air and it throws that air downward. That is the whole trick. The wing meets the oncoming air at a slight angle. The flow follows the upper surface as it curves away, and the entire stream leaves the back of the wing heading down. Push air down and the air pushes back. Newton's third law. The downward momentum handed to the air every second is matched by an upward force on the aircraft. That upward force is lift, not suction, a reaction. This does not make Bernoulli wrong. There genuinely is lower pressure above the wing and you can measure it. But pressure and deflection are not two competing explanations. They are the same event, described twice. The air is turned downward because the pressure above it is lower, and the pressure is lower because the air is being turned. Which is why the shape of a wing matters far less than most people assume. What matters is the angle at which it meets the air. A flat plate, held at a slight angle, produces lift. A paper airplane has no curved profile at all. An aerobatic aircraft fly on wings that are perfectly symmetrical, identical above and below. So why curve a wing at all? Efficiency. A curved wing turns the air more gently, keeps the flow attached at steeper angles and produces the same lift with less drag. It is an optimization. It is not the cause. The false version survives because it is short, because it borrows a real equation, and because it answers a question that has no honest one-sentence answer. Aerodynamicists have been complaining about it in print for more than 60 years. It is still printed on the card in the seat pocket in front of you. And that is the honest ending. We can calculate lift to within a fraction of a percent. We can design a wing on a computer and have it work the first time, and we still cannot explain it properly in one sentence. That is not a failure. That is just what happens when the simple story turns out to be a story.